clicked on this video, then you probably know what a DuckLake is. If you don't know what a DuckLake is yet, I definitely suggest you go and watch the 2 other videos I made about DuckLake, where I go through the quick start and then I get into more of a deep dive of how you can start a local DuckLake instance and do some cool stuff with it. But if you've gone through those and you're ready to take the next step, then this video is for you. Today, I'm gonna show you the fastest way to get a DuckLake into production. And it is with the help of our friends at MotherDuck. MotherDuck has once again offered a very, very nice and easy experience, this time in beta implementation into their ecosystem that lets you create a DuckLake and to read off of files in an S3 bucket, for example, like we'll be doing today. I wrote a Substack about this as well, and I will put the link to that to offer anything to people who would prefer to read instead of watch a video for this. But today we're working in MotherDuck specifically here, and you can see I've got a MotherDuck notebook up. If you're not familiar with MotherDuck, then you should definitely go and view the video I have where I review MotherDuck in its UI entirety, and I go through my thoughts and feelings of how I think the tool works. The TLDR is I think it's really, really good. And the way that it's built, it's going to allow us to effortlessly create a DuckLake. So there are a few things to consider here before you get started. One is you do need parquet files in a storage bucket, specifically S3 in the East 1 availability zone. For this demo specifically, and for MotherDuck in general, they suggest you to use S3 and put it into East 1. From what I understand, their infrastructure is centered around East 1. And so for optimized reads on their system, that's where you want to put your data. Now, not everyone is an S3 person. If you look, you can find some workarounds for GCS and Azure. I myself tend to use GCS, but I've kind of been forced to go start an S3 account myself and start to use S3. And I find myself using S3 now more often. So just keep that in mind that for this, you do need to go do some work and get an S3 bucket started in that availability zone and get your data in there. As well, you do need to set up a secret. You need to get access set up for that as well, because we're going to be bringing the secret and saving it here. So as long as you have your S3 bucket set up, you have your secrets built for it, and you have a few different batch parquets, you should be able to go right along with what I'm doing here and enjoy. Okay, let's jump over to MotherDuck now. So here I have set up a notebook, like I said. We're gonna go cell by cell and run some things and see what we have. But in MotherDuck, we've got a left side slide out menu that shows us our databases that we have attached to this MotherDuck instance. And then over on the right is a inspector that will pop up if we're looking at a table or there's anything else that we are zooming into. Okay, it's very, very straightforward to start a DuckLake in MotherDuck. I already have one called My DuckLake, but we're gonna create a new one called Manage DuckLake for today's video. But you can see here, we just create database, name that, and add a type of DuckLake. Very straightforward. Let's run this cell. And you can say 0 rows are returned, that's fine, we're not gonna have any. But over here, the Manage DuckLake shows up, and we now have our main schema that has been created in the DuckLake. There is no data in there yet, but we are going to change that very quickly. One of the things about DuckLake is that it is a lakehouse architecture. And what that means is it has metadata that is saved in some sort of persistent storage. In the previous videos I had, we actually used a DuckDB instance locally to save the metadata. And that works really, really well, but it doesn't quite work as well in a production state. Normally what you would do for production is use a Postgres database. And while I'm not completely sure what MotherDuck is using, what they're doing for you, the service they're offering is when you create a DuckLake here, they are building the metadata tables for you and they are storing it themselves. Thus why they suggest you also put your data in the same availability zone as their metadata tables that they're storing, from what I would assume. So when you put create database as a DuckLake in, it is going to create the metadata tables. It does let you run the DuckLake snapshots function though, and this is essentially running a SQL query that is grabbing a couple of the metadata tables and giving you an idea of what has changed over time. If we click on the DuckLake snapshots, we can see that we only have one here in the snapshot so far where we created the DuckLake schema called main, so that makes sense. But we'll be referencing this snapshot multiple times down in this notebook. Let's keep going. So now that we've got the DuckLake created and we've just peeked at the snapshot to make sure, okay, we see that, main's there and that makes sense. And we also see it in our file hierarchy. We're going to save the secret that we created for the S3 bucket. Now, obviously, I'm not going to put that in that here, and I've actually already created this, but all you need to do is put in your S3 access key, the secret key, the bucket region, and then the path to the bucket. And when you run this SQL right here, it will actually save it in MotherDuck. You don't have to do it via the UI. This is just really convenient. And I didn't know this actually could happen or if it existed. So when I saw MotherDuck add this in their original article, I was really impressed that you can do this. So you don't have to get into the UI and save your secret. Another pro tip is that you can actually look at the secrets that you have using a select statement here from DB secrets. And I'm bringing in just the names, but you can see I've got a few for some things that I've created. And that's just nice and convenient. So just in general, if you're ever having to use a secret and you're not totally sure what secrets you have thus far, you could go through the UI or you can just run that select statement and you can check it out. Okay, so from here we have brought in and created a DuckLake. We have brought in our secrets, which means we should have access to the S3 bucket that we need to use to read the parquets. You can see here, we're going to create a table in the DuckLake and we're going to call it streaming data. So within the managed DuckLake, we'll call this streaming data. And all I'm going to do is select all from a parquet file representing data. It's synthetic data from the date of 11/27. Keep in mind, this bucket is just a dummy bucket here, so I don't really have a problem showing the URI, but it will look something very, very similar to this. There are different ways for you to organize the data. I just have it this way. Let's run this and create a table. So we do have a row output at this point, 9,120 rows, and I know the data set, and that is the correct number of rows. Let's get over to the file tree here. We now have streaming data showing up under the main schema. So if I was to click on this in MotherDuck, I can see 9.12 thousand rows, which is what we want. And I can kind of work through the schema here, get a view, just some basic high-end metrics here for the schema. So the usual stuff we've seen in these types of tools, but it's nice because it gives us a validation layer as well. So we have created a table called streaming data, and we have brought in a day's worth of data that represents 9,120 rows. This is all, pretty straightforward so far. Where the production level comes in is, well, one, the fact that you are not having to manage any of the metadata tables right now. So MotherDuck continues to store changes and updates, and it keeps it in its, I'm assuming, Postgres databases. But all you have to do is basically call to the data, add it to your data set and your table in the DuckLake, and then you can look at the snapshots again. And we see here that after creating this table, we now have 2 entries in our snapshots. And again, these are coming from the metadata tables that MotherDuck is hosting and handling. But we see right here, there's our main streaming table added. So we are allowed time travel when we use this type of snapshot schema evolution. And while I don't have that represented here in this notebook, it is just something to note is we can go back different snapshot IDs and schema versions to see previous versions of how the data was. So this is just one of the really, really cool features of of the Lakehouse, and I think of DuckLake in general. So great, we've got our table created. Let's actually look at the data now here. So just a simple from, we're going to select everything, and we see the created data 1127. My created ats UTCs are a little wonky and are running into the next day. That's a happenstance of the way the data is created. But 1127 is the created date. That's what we're going to lean into. And you can just see a number of data points here. I use DLT to actually load the data into S3, which is why you have a DLT load ID connected to it. But I also do just want to note that, this data is a synthetic data set that I have running on a pipeline daily. So it's just very convenient to have something that's creating sort of dummy data for you. So you can always just try some tools out. I really highly suggest it. I have a Substack article on that as well of how I build those data sets, and I can also add that in the descriptions. Okay, so what we've done to this point is we've created the DuckLake in MotherDuck. We have added the secret so we have access to the S3 bucket, and we've brought in the initial data from an S3 file, parquet, to create our table called streaming data. Now, let's just say it's the next day now. It's now 11:20. We'll say it's 11:29. We're always going to grab the data from the day before. So yesterday was 11:28 and we uploaded 11:27 data. A whole day of business has passed since 11:29 now. Now our pipeline has spit out data for 11:28 into our S3 bucket. We'd like to append that to this current table that we have in MotherDuck. It is incredibly easy. You simply call the DuckLake add data files. Now, there are some different ways to do this. This is a very rudimentary, fast way to show you. This is an append of new files. It's just a batch append. And that's going to make sense. A lot of times, that's all you're going to have to worry about. But make no mistake, DuckLake does support upserting, like merging and inserting as well. And I don't use it that way. That's a little more of how a transactional database works, where you need to actually update a record or a specific record for, say, a customer. But a lot of, like in analytics, most of the time, I just want to get everything that happened the day before and then just append that information into a data warehouse. And then I will go and I can clean things as needed, or I can sort and order things as needed. So this handles most of your use cases, but all you do is just call it. You name the DuckLake, you name the table, and then you point to the parquet file that you want to append to the current table. And so if you just run that, it says 0 rows returned. However, that's because we were just calling a function. If we were to refresh the table here, I actually ran it twice, which I thought I might have done. But all that being said, it's 27.4 thousand rows now. So the 20th got in there twice. Not a problem, but that being said, you can see that that's all you got to run to get an append added to it. So if we now go to the snapshots, we see, right here, we see that there was 2 tables inserted. So there's 2 inserts. So I sort of ghost ran that cell and then I ran it again. I'll just probably use the play button, I guess, next time. But this is a very good example, actually, to show the way the snapshots tell you the behavior lineage. So let's think about where this would even come in handy. Well, hey, you're supposed to be getting, roughly 9,120 rows a day. So you would be expecting a little over 18,000 rows, but now you've got 27.4 thousand rows, and that count is kind of off. Well, we look at this and we can say, well, there was a double insert into the database. Now, one thing that we could do to eliminate that problem is to use an ACID transaction that has a requirement for that date of that data to not be in the data set yet, but we will get into that later. I think this is just a really cool accidental way to show that we can decipher that, hey, this version of the schema has the first initial insert and this has a second insert, and that actually explains why we have double rows. We go down to double rows for that day. Yeah, if we go down to here, we see 1127, and then we see 1128 again, and we're gonna see a lot of 1128. If I was to do distinct, we see the 18,240 rows. One of the things that we could even do right here, and I won't do it in real time, is we could go back a version in a schema and we could view that. I could also just recreate the table here as a distinct. And so the fixing this is not much of an issue, but I think it's really, really cool to be able to see that. So we've got appended data there. We've got the next day available. And let's say, we do want to get in some logic that says, hey, we don't want data being added in if it's already in there. So I have an ACID transaction set up down here. A lot of people, I think, act like they know what ACID transactions are, but when I have asked before, it turns out most people don't. And I think what actually is the case is ACID is just a term that I think is a little old. It's slightly outdated, but it references something that we already usually know as data people who are engineering pipelines and working on data sets. Is we want things or a set of criteria to be successful before we move forward with adding data to a data set. And that's really what an ACID transaction is doing. It's essentially saying that a set of criteria, a number of functions or steps need to successfully happen before the data will be added to the data set. The example that's already always given is transferring money. If you were transferring money to someone, you would first want to validate that that amount of money exists in your bank account. You then want to validate that the bank account, the routing number you are sending it to is valid. And then you would want to validate and have a successful response that the dollars did actually get sent over to that bank account. When all that set of criteria is successful, then you would say the transaction was a success, and you would ultimately respond, to the customer, the sender and the receiver, that this was successful. So it's a really good mental model to think about when it comes to an ACID transaction. What we have here is I am bringing in the next day, 1129 of data, and I'm asking to validate first that that date does not essentially exist in the previous data. So kind of coincidentally, what I did above would have been fixed by having this ACID transaction here. But what I'm working off of is the created at. I'm saying I want the minimum created at of this new data to be greater than the maximum created at of the data that's currently in the DuckLake table. And what that just, means in terms of what this data is, it says, if that's true, then this data is fine to append. There won't be any duplicate rows. If it's not true, then we want to error out, and we want to say there is out of order data detected. That could be a different error message. And then also this idea of rolling back the transaction. It does not automatically roll back. You have to manually hit rollback, but that being said, we're not going to worry about that. Just do understand it doesn't automatically roll back here. But if it offers a 1, if the case when statement returns 1, then we will call the DuckLake add file again like we did before, but we will add the 1129, the new data, into the table. So it's taking the new data, it's making it a temp file, then it's taking the temp file and it's comparing it to the current managed DuckLake streaming data table and giving a 1 if there's not going to be any duplication, and giving an error if the created at timestamps are not distinct from each other, from the max and the min. So let's go ahead and run this. All right, so you can see here, again, it ran no error messages, but we've got 0 rows returned. I'm gonna come over here again and I'm gonna refresh, and I do now have another 9,000 some rows added here roughly, right? If we come down to this cell, I've got a aggregate query here, and you can see We've got, well, the doubling of 1128, but we have 1127, 1128, and 1129 added. I will distinct that. And so, 111 just to kind of create the right number. But basically all these dates are being referenced now. So that's great. And we were able to do that very, very effortlessly. Now let's try something. Let me put back up in the ACID transaction here because I want to show rollback. Let me go put 02. I know that this does not exist in my parquet file. So this should give some sort of error, meaning, hey, there's probably a typo or something. Maybe something got switched. And so basically the transaction should error out. Let me run this. Great. So we get an error here, all right? Unable to connect to that. So that's an error out, and essentially the transaction ends. Now, I'm going to run this again, and I should be told, aha, transaction context error. The current transaction is aborted. Please roll back. So when you get an error message with your transactions, if there is an error, then the transaction is aborted. Now, to start over in a new transaction again, you have to roll back. Now, you can programmatically set this up, but I'm trying to show it within the steps. But if I run this cell, the rollback here, that does roll this back. And if I go into this again, there is a 30 in my S3 bucket. Let me run that. I've got 0 rows returned. Let me come here and check that. Let me accept that. Cool. And I've got all the dates accounted for here. Got all the dates accounted for here now. So you can see I tried to do a transaction, but the file was wrong, so I had to roll it back. I made the update, and then it did successfully commit. Let's now look at snapshots again after a lot of that stuff happened. So you've got the schema being made, you've got the table being created, and then you've got 1, 2, 3, and 4 inserts into the snapshots. Now, the transaction that failed is not part of the snapshot. It wasn't successful. And so we're not going to actually see that, but we're going to see, yes, when the 1, 2, 3, and then 4 were added in there. So, and then initially the table, when we did this, had an insert. So this was the first date. This one and this one are where I did them back to back. You can see they're 2 seconds between each other, which is why that metadata is really, really useful to have. It can determine some issues here. So this was the doubling up of the 1128 data. And then I did a transaction for 1129. Then there was a failed transaction. I rolled that back, ran it again, and 1130 went in. So at this point, this is how you simply build an interrogate a DuckLake and the data that's in it. From here, you could go over and set up something like a DLT pipeline that's going to actually automate this, and then you can be in the warehouse just reading it like any other warehouse you have. The data will just make its way in. It'll append via these calls. Keep in mind, all of these calls I have here, they can just be ran as SQL in Python with DuckDB, and then you can orchestrate it with DLT and say like Orchestra is a great orchestration tool. You can use that, and it's just happening in the background, and you're just coming in and you're reading it. But you're also offered the snapshots and some of the insight from the metadata. So if you do see things that are wrong and problems, you can roll back. You could do some time travel. These are more advanced methods that I am going to get into, but today I just wanted to show you how to get something up and running in a production data warehouse like MotherDuck. And I think what MotherDuck has offered here is just a fantastic opportunity to try it out for yourself. Stay tuned for something that might be getting built on my end to be able to let you be able to look at metadata. So all that being said, I hope you really enjoyed this. I love just what's happening with DuckLake, and MotherDuck is just there in parallel and offering some really great stuff. But I think the speed at which DuckLake is moving is super awesome, and I'm really excited to just keep building off of it. I had my aha moment with DuckLake some 6-7 months ago, and I've just been smitten with it since, and I've really fell in love with the lakehouse architecture. I really do enjoy it. So that's all for today's video. If you like what you saw, please like and subscribe. I also have a Substack where I am writing articles very similar and closely related to the videos that I do here on my YouTube. In case you like to read and copy and paste, you can go over there and I'll have all those links in the description. And as always, everyone, I hope you enjoyed the video and have a great day.